Good afternoon, everyone. Thank you for being here. My name is Jayesh, and I'm the Senior Director for Platform Strategy at Ampere Computing. I have Leigh Chen and Chang with me who will be co-presenting the Mount Mitchell server motherboard specification. Leigh, you want to introduce yourself?
Yeah. Hello, everyone. My name is Leigh Chen. I'm a platform hardware architect from Ampere Computing. Yeah.
So hey, my name is Alan Chang from Inspur, and representing Inspur for the product team, and then working with Ampere on the Mount Mitchell project. Thank you.
So I'm excited to share that Mount Mitchell specification was accepted at OCP, by OCP, and we submitted a 0.8 revision, and as we work with our partner, Inspur, we'll be submitting a Rev 1.0 version shortly. In addition to doing that, we will be sharing the design collateral, such as the schematics, the board, design files. In addition to the board, we'll also be submitting the DC-SCM 1.0 design files. The firmware that goes with it, it'll be OpenBMC firmware, and we'll also be submitting the Tiano Core EDK2 source code, so then the community can go and further innovate around both the specification, the DC-SCM module, and also the firmware. So as Ampere looks to 2023 and beyond, we see a need for a L-shaped implementation, and we'll talk about what an L-shaped implementation is. Essentially, the L-shaped implementation is a motherboard that has the power supplies next to each other. There has been effort within OCP for the DCMHS specification, and Ampere will be also joining that effort. But we believe that from a tier 2, tier 3 perspective, there is a need for a L-shaped motherboard. And so the Mount Mitchell specification is meant to fill that need. And Ampere is looking at it both from a North America, Europe, and also China market perspective as we develop this specification with Inspur. And so we'll talk a little bit about what the Mount Mitchell server is and the offerings or the flexibility that Mount Mitchell offers, as Inspur, our partner, has been working on a number of chassis around that. And so the motherboard does give a lot of flexibility if you're trying to create a system, whether you're trying to do a high storage, cheap spinning drive server, you're trying to do a 1U with E1.S drives, or just a generic general compute with U.2 drives. So the specification for Mount Mitchell is meant to be processor architecture agnostic. We have obviously designed it around the Ampere solution, but that doesn't exclude or preclude x86, Intel, or AMD also leveraging the specification. It can be a 1-socket or a 2-socket design, and Leigh will go into a little bit more detail on that. It is meant to go into a standard 19-inch rack, and the way it's architected, folks can implement it as a 1 DIMM per channel or a 2 DIMM per channel. From a PCIe perspective, it can support, in terms of the topology, insertion loss, things of that aspect. We can support Gen 5, Gen 4, and then downgrade that down to Gen 3, Gen 2 as well, if that's the need. The server specification that we've submitted.
Excuse us, your screens are popping back and forth between visible and not visible. Anything you can do to fix that?
Yeah, hold on. Thank you for that. So Should I use this, maybe? Or that's not going to help?
We have been having AV issues with the screens all day long, so we can try another adapter, see if it works any better.
Yep.
Well, I don't know if it'll stay, but let's give it a shot. Thanks for pointing that out. So Mount Mitchell also, as I mentioned earlier, supports DC-SCM 1.0, which was one of the initiatives at OCP. So we've taken that, we're demonstrating how to take DC-SCM 1.0, which is the specification for the module, and how it interfaces to the motherboard or the HPM. And we have submitted the specification for the motherboard, but as I said, we will submit the design files because the specification for DC-SCM is already available. So what we'll do is submit the design files along with the firmware for that. And so there'll be the motherboard aspect, the motherboard firmware piece that we'll submit, and we'll also submit the DC-SCM piece. And that way, from a community perspective, we hope the community builds Ampere-based servers, but like I said, it shouldn't preclude folks from looking at the design information and building other processor architecture implementation as well. It does support OCP 3.0 NICs, and then there has also been this push for the CRPS power supplies, and the Mount Mitchell server also supports the CRPS power supplies. And so the specification is uploaded, is at 0.8 version, and we're working over the next few months to upload the 1.0 version along with the design files. With that, I'll hand it off to Leigh, who will talk a little bit more about the motherboard specification.
Okay, thanks, Jayesh. So here we go to the Mount Mitchell motherboard specification, and you can see in the bottom of the page, we can see three motherboard options here. The first one is one socket 2TPC motherboard with 12 DDR channels. The second one is two socket 2TPC with 8 DDR channel. And the third one is two socket 1TPC with 12 DDR channels. Mount Mitchell at this moment picked option 2, but we have the capability to adopt the other two options based on customer requirement. And the Mount Mitchell design is based on the motherboard dimension is 424.9 millimeter in width and 422.9 millimeter in depth. And as listed in previous page, Mount Mitchell support the dual redundant power supplies and also support two OCP 3.0 NICs, as well as the OCP DC-SCM 1.0 module. Okay, let's move to the next page. Next page talk about the major component placement of Mount Mitchell. And the first, in the center of the motherboard, we place the CPU and memory. Right upon this area, which we call core zone, is the VR for the CPU and the memory. And you can see in the top center, there is a slim long connector. This is for M.2 interposer, which support up to two M.2 modules. We have pretty much yellow connectors, which is MCIO connectors, used for the cabled PCIe devices like E1.S and U.2. And in the right bottom side, we have two PSU connectors. And the left side, we have two white long connectors used for the PCIe risers. And at the bottom, there are three connectors. The middle one is for DC-SCM 1.0 module, and the other two is for OCP 3.0 NIC devices. Okay, thank you. So let's turn to next page. In this page, I will turn to Alan Chang, who from Inspur, to give us an introduction.
So first of all, it's really exciting to actually have a Mount Mitchell design spec. It's actually like Jayesh was saying, right? it's not just Ampere, but it covers the other CPU architecture as well. So one of the things like you might want to pay attention to is because of that, right? What can we do more in terms of the sustainability, right? As you can imagine, like a system integrator like us always have to recreate it, chassis, right? For a new CPU most of the time. But what happened is when we're talking about sustainability, can we actually create a chassis that fits multiple different silicon and allow we create less, design less, and then create more, right? For instance, like Mount Mitchell with Ampere is one of the architecture that we love to actually to be public available, and then we will make the product specific to it, and then contribute back to the OCP as one of the inspired product for you to purchase if you're interested in it. So as far as for the chassis goes, right, we actually make it a little bit traditional, conventional, a 2U box with 24 small form factor drive, and then a 2U box with a 12 small form factor drive as well. So conventionally, whatever your application is running on today on the x86, you can easily transfer that to Mount Mitchell with Ampere directly without any kind of storage change or PCIe expansion change. I think that's the beauty of it. And as far as for 1U goes, variety, there's 4 actually variety, including the back I/O. So the front, we're gonna have a 12U.2, which allow you to giving the most space for your traditional enterprise storage kind of concept. And of course, with the extra cores that Ampere was able to offering, I think having 32E1.S to actually pump up some sort of NVMe over fabric or centralized storage appliances, that could be potentially the application that you were looking for. I think that will be something to look for as far as for the Mount Mitchell spec, and then the spec that will contribute, product contributed to that. I'll let you talk about the DC-SCM. Yeah.
Okay, yeah. Yep. As we said before, Mount Mitchell start to support the DC-SCM 1.0 module. Here is the module details. You can see that on the first page, we have the UID button. Then we have the micro USB 2.0, which is used for the BMC UART, major for the debugger function. And then we go to the mini DP for the display output. And then we have the power LED to show the power status of the current systems. Then number 5 is 2 USB 2.0 port. And the number 6 is the RJ45 management port used for the BMC remote management. And go to the second picture, number 7 is a header for the external VGA port, mainly for the factory use in case there is no mini DP output devices. So we can use an alternative solution to use VGA. Then number 8 is the most important part on the DC-SCM module, which is the BMC AST2600. And the number 9 is the CPLD. Number 10 is the flash and socket. So we install the flash on the socket for the BIOS program. The last one is the TPM module. It's also a standalone module installed on the TPM socket on the DCM board. Thank you. Okay, next page is the open source. Let's go to the Jayesh.
So we are starting to get the open source firmware package, both for the BIOS and BMC and the DC-SCM collected, along with the CPLD code that'll do the transfer of traffic between the motherboard and the DC-SCM. So as that becomes available, we plan to submit that along with the 1.0 specification, along with the design files from Inspur, so the community can see how DC-SCM 1.0 is implemented with a motherboard. Next slide. And so as we're looking forward to what's next over the next few years, Ampere's already starting to work on its next reference design. We have the next generation of processors that we're starting to sample. You may have heard of that. And so we've already started to look at a board design that's similar to the effort that OCP has with DCMHS. And we're going down the path of modular architecture. We believe in the sustainability of servers and making sure that we can go down the path of having a modular architecture that can be reused. We can at least reuse the system boards along with the chassis infrastructure if we make the motherboard modular. And Ampere does plan to participate and contribute with the DC-MHS effort, but we're already starting to think about that in our next generation CRB that actually we'll be sampling pretty soon.
Oops.
So from a call to action, we've uploaded the specification. We would appreciate feedback on that. As Alan mentioned, we will have the server available in the marketplace shortly. And so if folks want to try that out, try out the open source firmware, and if you have any questions or need more information, do feel free to reach out to us. Thank you.
Good job.
Yeah.
Thank you. Hey, Allison.
Are you accepting questions?
Yes.
How does it handle CPU to CPU interconnect, right? Everybody has their own standard. Yeah, how do you do that?
So Ampere uses a standard called C6.
Yeah.
And that's what we are using for the processor-to-processor interconnect.
And what's the maximum core count of Mount Mitchell?
So we'll share that shortly. We haven't made
I tried.
good question, but we haven't made that public yet. Any other questions? It'll be more than Ultramax, which is 128 cores. All right, thanks everyone.
Thank you.
Thank you.